Okay, Assalamualaikum. Let's continue our sessions today. So we can see that hypothesis testing we have covered the first one, the traditional method. This one is finished, and then we also covered the second subtopic, which is a z-test for a mean. So today I will cover the t-test for a mean. So you must remember that the difference between z-test and t-test is the differences of a table. So table E for z-test, table F for t-test. Okay. Okay, the other difference between z-test and t-test is you must remember that uh, the value for standard deviation. So standard deviation for z-test, we know the standard deviation. But for the t-test, we don't know the value for the standard deviation. So what is t-test? Okay, t-test for a mean is a statistical test for mean of a population. So population, it must be normally and approximately normally distributed. Okay, this is the first one. And the second one is the value for standard deviations is unknown. Okay. And then the third one is n equal to n must be less than 30. And the fourth one, you must remember that we are going to use a table F for the t-test. Okay, so this is a formula for t-test. So t equal to average minus with mean over standard deviation divide by square root of n. N is a number of sample. Okay, and then we also use a degree of freedom. So degree of freedom is n minus with 1. So let's see the example. But before that, you can see your slide. So your slide here, this one, the first two lines is about what is a t-test, and then the slide shows the formula for the t-test. Okay, let's see the first example. Find the critical t-value. So t-value, so for the t-value, it's the same for the z-value. We have three types of critical value. The first one is a right tail, left tail, and two tail. Okay, let's see if for the first example, alpha equal to 0.05 when the degree of freedom is 16. So when you draw your binomial distribution, okay, you can see that alpha equal to 0.05 for the right tail is here, 0.05. Okay, let's see table F. So table F already, he said that T distribution. And for table F, there are three columns, confidence intervals, one tail, two tail. So you must remember that for the right tail and left tail, we're going to use the one tail only. For the two tail, we're going to use here, the third column. Okay. Then, okay, let's say alpha equal to 0.05. Okay, alpha for one tail, because right tail, 0.05 here. And degree of freedom is 16. This one. So the result is the critical value for t value, critical t value is 1.746. Okay, how about the second example? Second example is alpha equal to 0.01. The degree of freedom is 22. Okay, so alpha 0.01. So alpha 0.01, 0.01, degree of freedom is 22. So here, 0.01 degree of freedom is 22. Okay, 2.508. 2.508. Okay, but because of the left tail test, so for the left tail test, 2.508, you must put negative here. So the critical T value is equal to negative 2.508. Okay, and then for the third example, alpha equal to 0.1 for two tail, 0.1. So 0.1, okay, two tail 0.1 here, degree of freedom is 18. Okay, so 1.734, sorry, 1.734. So the result must be two results. The first one is a positive result, 1.734, and then the second result is negative result, negative 1.734. Okay, so this is the correct answer. Okay, let's continue with another example. Okay, this example. Okay, medical investigations claim that the average number of infection per week at a hospital in southwestern US is 16.3. Okay, so 16.3 we put as an average, so average here. And then a random sample of 10 weeks, okay, random sample is equal to n. Mean number of had a mean number of 17.7 infections. So 17.7 is equal to mean. And standard deviation is 1.8, equal to standard deviation. And alpha is equal to 0.05. Okay, for the first step, we must state the hypothesis and identify the claim. So H null equal to mu equal to 16.3. Yeah, and H1, okay, how we want to know whether this is a right tail, left tail, or two tail. Okay, because in this example, they didn't stated whether it is increased, higher, lower, or decreased. So we assume that this is a two tail example. So you just use tak sama dengan for two tail. Okay, when saya note kat sini, dia kata dia tak bagi tahu, so we assume tak sama dengan. Okay, so the example is about the two tail test. Okay, kemudian for the step 2, find the test value. So test value ni we use the formula for t-test. So you just insert everything in your formula and you will get the answer is negative 2.46. Okay, and then after that, before step 3, you must find the critical value. Critical value is in step 2, find the critical value. So find the critical value. We know that alpha is equal to 0.05. Degree of freedom is 9. How do you want to find the value for degree of freedom? So degree of freedom is coming from the value of random sample. So random sample is equal to 10. So 10 is equal to n. So degree of freedom, n minus with 1. So equal to 9. So our degree of freedom is 9. So tengok table F 0.05 for degree of freedom 9 adalah 2.262 and negative 2.262. Okay, this one is for the second step. For the third step adalah kita cari find the test value. And the fourth step adalah we want to make the decision whether we reject or we do not reject the null hypothesis. So you can see that here, okay, when you draw 2.2 Okay, let's see. Let's say here is 2.262. Okay, this one is a critical value. So test value is here, 2.46. Okay, so because of since 2.46 is greater than 2.262, so therefore we reject the null hypothesis. Okay, so the last step is summarize the result. So summarize the result. There is enough evidence to reject the claim that the average number of infections is 16.3. Okay, that's all.